Hello and welcome to the session. Fundamentals of Chemistry for Medicine LO1. Understand basic atomic structure and the arrangement of elements in the periodic table. What makes an element unique in chemistry? Discover the core of atomic structure and its significance in the periodic table. Unveil the mysteries of protons, neutrons, and electrons that define elements. An atom is the smallest unit of an element, retaining its properties. It consists of protons, neutrons, and electrons. Protons, with a positive charge, define the element. Neutrons, neutral in charge, add mass and stability. Electrons, negatively charged, influence atomic reactions. The nucleus contains protons and neutrons. Electrons orbit in energy levels around the nucleus. The atomic number equals the number of protons. Mass number is the sum of protons and neutrons. In neutral atoms, electrons equal protons. This arrangement influences chemical properties. The periodic table is organized by atomic structure. Elements in the same period have the same number of electron shells. Groups share the same number of outer electrons, leading to similar properties. For instance, Group 1 elements are highly reactive. Group 18 elements are unreactive. An element's position in the periodic table relates to protons, electron shells, and valence electrons. This structure helps predict behavior and bonding. Scientists use this information to understand reactions. Atomic structure is key to chemical properties. The periodic table is a predictive tool. Atoms consist of protons, neutrons, and electrons. Protons are positively charged and define the element. Neutrons, with no charge, add stability. Electrons, negatively charged, move in energy levels. Each particle plays a distinct role. The atomic number is the count of protons in an atom. It is unique for each element. In neutral atoms, it also equals the electron count. The mass number sums protons and neutrons. Electrons are negligible in mass calculations. Isotopes have the same number of protons but different neutrons. They share chemical properties but differ physically. Isotopes have the same atomic number but varied mass numbers. Relative atomic mass averages isotopes' masses. It accounts for natural abundance. Graphs illustrate how element properties change in the periodic table. Trends include atomic radius, ionization energy, and electronegativity. These trends show predictable patterns. Understanding them aids in chemical predictions. Graphical interpretation is crucial. Atomic radius decreases across a period. This results from increased nuclear charge pulling electrons closer. Down a group, atomic radius increases. An additional electron shell is added, increasing size. Atoms shrink across periods and grow down groups. Ionization energy rises across a period. Increased nuclear charge holds electrons more tightly. Down a group, ionization energy decreases. Outer electrons are further and shielded, requiring less energy to remove. Removing electrons becomes harder across periods. Electronegativity increases across a period. Atoms attract electrons more strongly. Down a group, electronegativity decreases. Increased atomic size and shielding weaken attraction. Atoms attract electrons more across periods. Reactivity varies between metals and nonmetals. Group 1 metals increase in reactivity down the group. Outer electrons are lost more easily. Group 7 nonmetals decrease in reactivity down the group. They gain electrons less easily. Graph interpretation involves trend direction and atomic structure. Trends can be increasing or decreasing. Changes occur across periods or downgroups. Atomic structure, such as charge and shielding, explains trends. Graphs reveal predictable element patterns. Protons are positively charged and reside in the nucleus. They have a relative mass of 1. Protons define the element's identity. They are stable and do not move. The atomic number equals the proton count. Neutrons have no charge and are in the nucleus. They share a relative mass of 1 with protons. Neutrons stabilize the nucleus and add mass. Atoms can have different neutron numbers, forming isotopes. Neutrons do not affect the atomic number. Electrons are negatively charged and orbit in energy levels. They have a negligible mass compared to protons. Electrons are crucial in chemical bonding and reactions. They determine how atoms interact. Electrons equal protons in neutral atoms. The atomic number is unique to each element. It equals the number of protons in the nucleus. In neutral atoms, it also equals electrons. The atomic number defines the element's identity. It is crucial for periodic table placement. The mass number is the total of protons and neutrons. It indicates the atom's mass, but excludes electrons. Electrons have negligible mass. Mass numbers vary for isotopes. The mass number is not shown on the periodic table. In conclusion, understanding basic atomic structure and the arrangement of elements in the periodic table is fundamental to the study of chemistry for medicine. Knowledge of atoms, subatomic particles, and atomic number explains how elements differ and how they interact. The periodic table organizes elements according to their properties, allowing patterns and trends to be identified. This understanding provides a foundation for learning about chemical reactions, biological processes, and the role of elements in medical science. Thank you for watching this video. If you have any questions, please feel free to contact us via email or WhatsApp at 074843616888.